Okay, guys, question 1 on the 2019 paper. Hopefully there's nothing distracting you at home. Can't say the same here. Okay, so the first thing you're going to be working out is the range of the data. Now the range of the data is the top value, take away the bottom value. Okay, the top value, take away the bottom value in this case would be 31. Okay, no matter there. Still lots of distractions going on here, guys. All right, write down which of these heights is an outlier. Give a reason for your answer. Now, an outlier would be a result that is basically out of the ordinary. Okay, so what we say is, I suppose if you take the next lowest value is 165, take away from 172, so the rest of the data has a range of 7. Because of the presence of 141, the range is 31. So you'd definitely say 141 is the outlier. Oh, sorry, I have to do that underneath. So what we're going to say here is that, guys, the rest, the outlier is 141. Give a reason for your answer. Well, the rest of the range has a, the rest of the data has a range of 7. Because you took 172, take away the next smallest one, 165, equals 7. You can just say rest of the data has a range of 7. You could say anything like basically 141 is 24 below the next nearest point, and that in turn is only 7 below the maximum value. So it's really 141. Bringing down the height, so there's one short student compared to the rest of them. Work out the mean of the data, give your answer in centimeters. Well, look, the mean of the data is basically, you're just going to add them all together, so you're going to get 141 plus 141 plus 165 plus 167, 168, 169, 167 plus 168 plus 169. Then we have the mean is basically the average, guys. Okay, plus 170 plus 172 plus another 172. Okay, and how many numbers is that in a row? Well, that's 8 numbers, so we divide by 8, and then we should get an answer of 165.5 centimeters to be the mean. Okay, so the mean means the average height. Okay, let's move on. D. John measures the heights of the teachers in his school. And what he's basically saying is that most of the teachers in his school have a height greater than 175 centimeters. Put a tick in the correct box to show each of the following statement must be true based on what John says. The mean of the height of the teachers is greater than 175. Okay, let's think about this, right? Most of the teachers in my school have a height greater than 175. So let's take a really small example, like 175, sorry, greater than 175, excuse me. So let's take an example of 5 teachers in your school. So 176, 177, 178, okay? And then below that, we could go like exceptionally short, like 130 and 131. Okay, now these are 5 teachers, and most of the teachers are above 175, so it applies to the statement here. Okay, but let's test if the mean would be let's see if the mean would also be below or above 175. So 177 plus 178. Okay, that's 900 and 792. Then we can divide that by 5, and look, we can see that the mean is below the 175 mark. So we know this to be wrong. Okay, so we just have to prove that to be wrong. The next one, the median height of the teachers is greater than 175. I think in this case that's going to be true, because look, despite having having 2 really low numbers, the median or the middle term of 5 numbers, you do 5 divided by 2 and you get 2.5, round it up to the third person. And you definitely know, because most of the teachers have to be above 175, this means that the middle teacher and above always have to be, they need more than 50% to be above 175. So we definitely know this is true. The mean height of the teachers is greater than 175. True. The modal height of the teachers is greater than 175. Now we know that to be false because once again, I can make a new system like this. I can change that 131 to 130. My mode is my most common answer, and in this case 130 is the mode, which is below 175. So once again, that wouldn't work either. Only the middle answer can be true. Okay. Question 2. The following was asked as part of the survey. How do you travel to work? Circle one of the answers. Okay. So it's important that we know what type of data this is. This is categorical nominal data because there's no order and each answer is in categories, so it can't possibly be numerical answers. It can only be either ordinal or nominal. Ordinal implies an order like A, B, C, D, first, second, third, fourth, fifth. There's nothing to say that a car is better than a bus or a train or a walk or a cycle. It's very subjective. So in this case, it has to be categorical nominal. Okay. The next one, the table gives us a basically information about the way men and women traveled to work in 2006 and 2016. We got to fill out the following chart. Well, look, they all have to add up to 100. So what you do is you get 100 and you take away 1.2, 71.4, 11.3 and 15.4. And your answer will work out to be 0.7. Okay. Likewise, you get 100 and you take away 15.3, 62.6, 8 and 12.1. And your answer there will be 2.0. And then finally, what you all know is that everything has to add up to 100. So when you add up all of these together, your answer has to be 100. Write down the modal way of traveling, the mode for both men and women. Now this is the most common way of traveling. So what is the most common way people travel? Well, we can see for men and women, men 62.6% of men take the, in 2016, better make sure I have the right one. So not that one. 2016 is these ones over here. 60% of men use the car in 2016, as does 71.9% of women. This implies that car is the most efficient way, is the most common way of traveling, which means the modal way. We already filled out the table above, already done. Okay. Evie says in 2006, women were more likely to walk or cycle to work than men. Show that Evie is correct using the numbers from the table. Well, if we go back to Evie, we can see that walk or cycle. There we see it there. Women are at 15.4, while men are at 12.1. So we say there is Evie is correct because 15.4% of women walk or cycle compared to only, now what's the next thing, only how much men again? 12.1% of men. Okay, we're all good there. Now, next thing, Alison says more women must have travelled to work by car in 2016 than 2006 because 71.9% travelled in 2016 but only 71.4% travelled in 2006. Is Alison correct? Well, think of it this way. If it was the same amount of people, she'd be correct, but there's no guarantee it's the same population. So I'll give you an example of what I'm talking about here. 71.9% of, let's say, a population of 1,000 would equal 719 people, while 71.4% of a population of, let's say, 500 would equal 71.4% multiplied by 500 would equal 357 people, all right? Or vice versa. So sorry, what I really meant to say was the higher percentage multiplied by 500. So 71.9% of 500 people would be even though it's a higher percentage, it could technically be less people, like roughly 360 people, while 71% of 1,000 people would be 714 people. Even though this is the lower percentage, it contains more people. So what we have to do is we have to look at the population of each year, right? So we're going to get 71.9% of the and 71.4% of the population of each year. So what's the population of each year? Let's see if we can find it. It doesn't really tell us. So I suppose it's my answer there, I suppose. So okay, let's see if we can find something that will help us out here. All right, we don't know that. So what you can say is 71.9% of a smaller population is less than 71.4% of a larger population, as I explained earlier. And Alice said must have, so she was being definite, like this 71.9% has to be bigger, but we know that's not true. Okay, let's go to F. In 2016, roughly 990,000 men and 880,000 women traveled to work. Use the figures in the table to work out the total percentage of people who travel to work. Okay, and bus or train, by bus or train in 2016, right? So we have 990,000 men, we have 880,000 women, and we're looking for the bus or train statistics, okay? So let's look up for bus or train here. So we're going to use 8.3 for men and 10.5 for women. So for men, we're going to multiply by 8.3%. And for men, we're going to multiply by 10.5%. So this means roughly 82,170 men travel to work by the bus or train, and 92,400 people, or sorry, women traveled by bus or train. Add them together and we get 174,570 people in total travel by train or bus. Now to get the percentage of people, we need the percentage of people who used the train divided by the total number of people multiplied by 100, and that's going to give us the percentage of overall percentage of people that travel to work by train or bus. So we're going to add your 990,000 to your 880,000, and what we should get is so we're going to add the 990,000 to 880,000, and we should get 1,870,000 people. Okay, and then above that we're going to use our 174,570. We expect our answer to be somewhere between 8.3 and 10.5 when you join both results together. Okay, and as it turns out, that's bang on. The answer is 9.3353%, but we wanted to three significant figures. Now remember, a significant figure is going to be the 9 and then the 0.34%, like so. Okay guys, we're going to move on and do the next question. G. So we're going to have to put all these into a pie chart, and let's see how this goes. Okay, so what we're going to do is we're going to work out the percentage of men. So to change stuff into an angle, imagine this, all right? So a full circle, for an example. So if I have a circle here, like so, and I do this, that's a full circle, okay? And a full circle, 100% basically equals 360 degrees. Okay, what we have to figure out is how much does 12.2% equal? So it's going to be 12.2. So 12.2 divided by 100 multiplied by 360. It's what fraction you got multiplied by 360 tells you what portion of the 360 you're entitled to. Imagine, for example, in a test you got 10 divided by, imagine for some reason you got 10 out of 20 euro. This means that you would have essentially 180 degrees or half the pie chart because you got half the money. Okay, so something like that. Okay, so you're going to do the percentage divided by 100 multiplied by 360, and we're going to have to do all of these. We're going to keep changing percentages into angles here, and then what's it, 60 over 100 multiplied by 360, and then we're going to have 14.2 over 100 multiplied by 360, and finally 5.3 over 100 multiplied by 360. We're going to put all of these into the calculator individually, and then we're going to try and work them out. Okay, so this one is going to be 43.92, I'll round off to 44. Then we got 29.88, no bother. Then we got 60 divided by 100, so that's the majority, the car is the majority of it, so it's going to be quite a large angle, 216 degrees to be precise. This one over here, the what's it called, the other is small part, so it's going to be 51%. I'll say 51.12. And then finally the other one, the not stated, is going to be not stated is going to be 19 degrees. Okay, sorry, 19 degrees, not 190 degrees. Okay, next thing you're going to do is try and get out your protractor. Okay, what you want to do is you want to start off towards 90 degrees. Now the first one is, we're going to have to round some of these off, alright? So the first one's going to be 44, the second one's going to be 30. Oops, I must get this thing out of the way. We're going to round that off to 30. Next one's 216 degrees. We're going to round this one off to 51. And finally the last one, just 19. When you're rounding off, be sure that they all add up to 360 degrees. So 44 plus 30, just to make sure that you rounded them all off correctly, plus 216. And then what's a 51 and 19 left over? So 216 plus 51 plus 19. And what we should get there is 360 degrees, no bother. Okay, so what we're going to do next is we're going to set up this compass, and we're going to try and do some of these angles now. So the first angle I'm going to do is I'm going to do the 44. Okay, so see the 40 there, but you want to sort of try this one more time. You want to draw 40, but then see up here you can go 1, 2, 3, 4, just below the 135 mark. So you want to go about 44 degrees around there. Okay, then you want to recycle or just move your protractor across, so you're back at the 0 mark again, like so. And then you're going to go for 30 degrees, which is this mark here. Then the next one you're going to go for is 216 degrees. So once again, you're going to cycle around back to 0. And I'm going to have to move this down. So we're going to try and get 216 degrees here. Now 216 degrees is actually above halfway, so I'm going to do the smaller angles first. And what should be left over is 216 degrees. So let's do 51. So there's 50, and around there will be 51. And then we're going to do 19. So once again, just move it across until it hits the 0 mark. Then we're going to do 19, which is obviously just one shy of 20. So there's 19, there's 20 there, and then we'll just go a little bit in for 19. And then what's left over will be your 216 degrees. Now, when you're doing a pie chart, it's probably important you label, you want to label your angles and what degrees it was. So we'll put this as par, and that'll be 216 degrees. Okay, this one was no, I forgot to start. At the very start I went straight across, because at the very start I did 44 degrees. Yeah, now I remember now, so should have drew that line in there. So that would be walk/cycle. Walk or cycle, that's 44 degrees. And the next one after that will be the 30 degrees, which was bus or train. 30 degrees. And the next one after that was the 51 degrees, which belonged to the other. And then finally, the 19 degrees that said not stated. 19 degrees. Okay, and now we're done. There's our nice pie chart, done and dusted. Alright, already did that. Remember, it says label each sector and the size of the angle clearly, so it's very important that you do that. Okay, let's move on. The next diagram shows the main ways that primary school students travel to school from 1986 all the way to 2016. So we see in the early days, most primary school students walked or cycled, because you can see that this is up at 50% in 1986. The car was down roughly at 24%, and then the the bus or train just below 20, let's call it 19%. Okay, as time goes on, we can see that the amount of people that walked or cycled decreased somewhere towards 25%. Okay, the amount of people that take the car just below 60%, so around 58% or so. And then the amount of people that that got the bus or train decreased slightly to about 11 or 12%. I can't really tell from the graph too accurately, but that's the main gist. Write a paragraph to describe the information the given diagram says about the way primary school students traveled to school over the period of 1986 to 2019. In your answer, you should use the information in each of the 3 lines of the diagram. Well, look, I'm going to speak about this. I'm not necessarily going to write the paragraph, but here it goes. In 1986, roughly 50% of all people walked or cycled. As time went on between in the 90s and the early 2000s, this decreased to around 25%. So it was 1 in 2 people were walking or cycling to school. Now it's only 1 in 4. Conversely to this, or in the opposite to this, only roughly 24% of people took the car to school, students took the car to school in 1986. As time went on during the 90s and early 2000s, this rose to 58 degrees. Okay, so we can see a drastic increase in the people traveling by car. And then eventually the bus or train, there was 19% of people, and this only fell a little over time. Actually, the people using bus or train rose slightly in the early 90s, but then it started to fall gradually and then reached a low of roughly 11% or so in 2016. Okay, so less people are using the bus or train than they were in 1986. Okay, guys, you just got to write that down. End of story. Okay, let's move on. Now, we're going to have a look at this now. Okay, so this question goes, the coordinate diagram shows the screen of a digital clock at 1500. And it goes, the images of P, Q, S, and T of the screen under 4 transformations as follows. So we can see there's different looks for the clock, okay? And what I want from us is complete the table below to match each of the transformations that are produced. Use each letter P, Q, S, and T only once. Okay, so we'll start off explaining what axial symmetry in the x-axis is. I'm going to use the number 15 to show you what this means. Axial symmetry in the x-axis means the following. See A, it takes A 1 block to get to the x-axis. So this means there'll be another A 1 block away from it above. Look at B. B is 2 blocks above A, so B will be 2 blocks above it here. So that implies that's symmetry in the x-axis. D is one block away from 3, so on the other side, a mirror D will be the same distance away. E is one block above D, so that will be E. Then C is one block below 5, so that means C will be one block here. F is one block above C, so that will be there. G is one block above F, which is G. And then H is one block above E. And then we can make our 5 once again by linking C to D, E to F, sorry, C to E, C to D, sorry, D to E, E to F, G, and then to H. It's basically a mirror image in the x-axis, okay? So a 15 will actually look like a 12, okay? So what we're looking for here is something that looks like 1, 2, 0, 0 when we're talking about the x-axis, okay? So, excuse me. So let's have a look. Okay, which one is it? So we have to look for 12. Well, I think it's image S. I'm definitely looking at image S for that one, okay? So let's go for image S. Okay, axial symmetry in the y-axis. Let's go back here. We'll just rub out what we did here a second ago. This time we're doing it in the y-axis, okay? Look at A. A is 2 blocks away from the y-axis, and it's along the line -1. So this is A on the other side. B has to stay 2 blocks below it. So B is 2 blocks to the y-axis and 2 blocks out. This is A. Next thing, D, which is 3 blocks out, should remain 3 blocks out. D. And then 2 blocks away from D is C. C is 5 blocks away from the y-axis, so it will remain 5 blocks away from the y-axis. That's your C value. And then below D needs to be E, so there's your E value there. F is 2 blocks to the right of E, so on the other side it'd be 2 blocks to the left. And then G, which will be at 5 as well, because it's 5 blocks away from the y-axis. And then H will be 3 blocks away from the y-axis. And once again, we got to link them up in the same manner. C goes to D, D goes to E, E goes to F, G, F goes to G, G goes to H. So we can see the reverse of that. 15 sort of turns into 21. So what we need to be looking at here for the y-axis is, we can see it there, the 21, the 15 turned into 21. And the 2 zeros, if they were to be there, would appear on the opposite side. So 0, 0, 2, 1 by the looks of it. Yeah, image T for axial symmetry in the y-axis. Now translation is where you move everything, but everything stays in the same shape. So translation is basically everything moves and it stays in the same shape. So it'll still stay as 15, so that'll be image P. Okay, because what is a translation? Well, let's take another example. Let's say we took a translation of moving everything across, let's say 2 blocks left, 2 blocks left and 3 blocks up. Let's imagine this for argument's sake. 2 blocks left, 3 blocks up. Actually, we need to do it a bit further. I want to clear it. Let's go 2 blocks left and 5 blocks up. Let's try it this way. 2 left, 5 up. 1, 2, 3, 4, 5. That'll be your new A. B, 2 blocks left, 5 blocks up. There's your B. So there's your 1 is still 1. D, 2 blocks left, roughly 5 blocks up. There's your D. And then C, 2 blocks left, 5 blocks up. And we can see that the picture is being maintained. 2 blocks left, 5 blocks up. H, 2 blocks left, 5 blocks up. So we can see that the picture is coming out exactly the same. So if that's the case, then it must also be the same shape. So there we go, 15 turns into another 15. This, as we said, means it was P. Okay, no shape is given. And by process of elimination, the last one is central symmetry in the origin. So that must mean, what's it, PQ, that must be Q. But let's look at what central symmetry in the origin actually means. Well, central symmetry in the origin means this, guys, that you go to the origin and you go the same distance out. So for example, A goes 2 blocks and 1 up to get to the origin, then it must go another 2 blocks, 1 up to pop out the other side. So this is A on the other side. Next we're going to do B. B goes 2 blocks left and 3 blocks up to get to the origin, then it must do 2 blocks left and 3 blocks up to get up here. So that's BA right up there. We see that's almost upside down. Let's do D. 3 blocks left, 1 block up. And then we're going to go 3 blocks left, 1 block up. There's our D right there. C goes 5 blocks left, 1 block up. Then it's going to have to go another 5 blocks left, 1 block up. And there's C. Now we're going to go for G, which has to go 5 blocks left, 3 blocks up, 5 blocks left, and then 3 blocks up for G. We're starting to get a gist of it now. So that would mean H would end up above D, and then it'd be C to D, then it'd be D to E, E to F, G, H. And see the way it's sort of the opposite way around. Okay, so that's why for this question here, the 15 would be the opposite way around completely, and it'd be like it rotated. It'd be like it spun around. So basically, if you were to, anytime you go through central symmetry, if I was to take a snip of this, okay, and keep it on the same page, and obviously make it to order of size, what you're essentially doing when you do central symmetry is it's almost like you're doing a rotation like so. So you're doing like a full, that's it, that's 90 degrees, that's 180, it's basically 180 degree rotation, and that'll be central symmetry. That's what central symmetry looks like, as I proved over here. Okay, so there we go, we got all that done. Explained in a lot of detail. The diagram shows the center of a circle of a soccer pitch. The center of the circle is marked at the start of the game. Gary and the referee stand at 2 points at the circle G and R. Okay, so they're standing at G and R, as shown. No bother. So what does it want from me then? It wants me to go, Jorge stands at the point J on the circle, so that the angle at the referee is 90 degrees. Jorge stands at the point J in the circle. Using a straight edge, construct a point J in the diagram, label the point J. Okay. So, okay. Jorge stands at a point J on the circle, so the angle at the referee is 90 degrees. So where's Gary? So that the angle at the referee is 90 degrees. So what we remember from our geometry course is that basically when you have a diameter of a circle, okay, when you have 2 points as a diameter, let's say point A and B, any point C that's not on AB, so it could be point C here, that automatically makes a right-angled triangle. Okay, if I did a point D up here, that would also make a right-angled triangle. No matter what way I organize it, it's going to be at a right angle. So what I suggest is we get a line from Gary, we go straight through the center of the circle, and then we have, this is the point J for Jorge, and then we can clearly see that the referee is now at 90 degrees to Jorge and Gary. Okay, State the theorem or corollary to justify our construction in part B. Each angle in a semicircle is a right angle. That's what we're going to say. Okay, so let's type this out. Each angle in a semicircle is a right angle. Okay, basically any 3 points in a semicircle, provided 2 of them are a diameter, makes a semicircle. Okay. Alright guys, question 5. So we have a coordinate diagram as shown, and what we're going to do is we're going to basically label the points. Okay, so look, this should be relatively easy for everybody here. Shop is -3, 1. Home is 4, 2. Skill is 4, 5. Happy days. Okay, so that's done. Once again, just going to write these down. -3, 1, 4, 2, 4, 5. Okay. The library is the midpoint between home and shop, right down the corners of the library. So midway between home and the shop. I think we might just use the midpoint formula here. Okay, so the midpoint formula is on page 18 of your log tables. X1 plus X2 over 2. Y1 plus Y2 over 2. Home and the shop, so call that X1, Y1. Call that X2, Y2. And what you're going to get here is -3 plus 4 over 2. And then you're going to get 1 plus 2 over 2. So we're going to get a half on the thing, and then 3 over 2. So it's basically a half, it's basically 0.5 and 1.5 if you're being technical. And where is it? 0.5, 1.5? Roughly here, which we can see is halfway between the shop and home. Happy days. Okay, what else do we have to do? Work out the distance from home to the shop on the diagram. Give your answer in centimeters, correct to 2 decimal place. Okay, so home to the shop, let's see. So we need the distance of home to the shop. So what we're going to use here is the distance formula. Okay, so once again, we're just going to chop the 2 of these here. Home to the shop. Set on current page here, like so. Then we're going to use these points to determine using the distance formula. So once again, on page 18 of your notes or on your tables, you have a distance formula, and this is what we intend to do. So x2 minus x1 squared plus y2 take away y1 squared, and what we get is 4 minus -3. Remember, the minus belongs to the formula, the other minus belongs to the point, but we know that 4 minus -3 is actually 4 plus 3 to be squared. And then the other one is y2, which is 2 take away 1 squared. Now you can put all of this into the calculator, no bother. And when you put it all into the calculator, what you should get is the square root of 50, or 7.07. If you're wondering about the calculator, just put root 50 in like so, and we get 7.071, so I round off to 0.07. Okay, the distance in the diagram from the shop to the school is roughly 8.1 centimeters. The diagram is a scale of 1 to 2,500. This means it appears 2,500 longer in real life. So you multiply your 8.1, multiply with 2,500, and what you get there is 20,250 centimeters. Okay, so that's 8.1 multiplied with 2,500. Now we have to give the answer in meters, and we know that 1 meter equals 100 centimeters. So we're going to have to divide this answer by 100, and when we divide that answer by 100, what we're going to get is 202.5 meters. Okay, that's done quite quickly. Now, next thing we got to do. Clodagh walks from the shop to the school. Explain why the distance she walks is probably more than the actual distance from part D. Clodagh walks from the shop to the school. Well, in part D, part D, the distance. Okay. Okay, so in the diagram, okay, if you go back to the diagram, so she goes from the shop to school. Oh, sorry. Let's see what she does again. Her distance in part D. Part D. Alright, so we see it's 8.1 centimeters in part D. So we're told that shop to school is roughly 8.1 centimeters, which we know that turned out to be 202.5 meters in real life. But look, it's very unlikely that the shop, this is the answer you write down, guys, I'm not going to write it down myself. It's very unlikely that you can go in a straight line from the shop to the school. Usually you have roads and obstacles to go by when you're traveling from one place to another. So you're not going to go in a perfectly straight line. So this is why you're going to end up completing a bigger distance in real life. Okay, that's the answer to that question. You can write that down. Okay, so just listen to audio for that. So you get the answer I just said there a second ago. Okay. Now, the coordinate diagram below has a line L drawn from the shop to the school. The angle is marked with an angle A as shown. Okay, so what does it want us to do? Work out the slope, give the answer as a fraction. Well, we can do this in two ways. We can do either slope equals rise over run. To do rise over run, all you need to do is pretend that you're in like a Super Mario game. And what you're doing here is going across and up. So how many blocks do you go across? 1, 2, 3, 4, 5, 7 across, 4 up. It's a positive slope because if you're playing Super Mario, you'd be running left to right, which means you're running up a hill. Up a hill is a positive slope. Down a hill would be a negative slope. Okay, so this is definitely a positive slope. So you can just do rise over run and your answer would be 4 over 7. Another way of doing it is to use your slope formula. Pick any 2 points on the line. So I can pick minus 3, 1 as my first one. That'll be my x1, y1. And this one here is 4, 5. That'll be my x2, y2. The slope formula is y2 minus y1 over x2 minus x1. Once again, available on page 18 of your notes. I do it like this using open brackets, like so. Then you put in your numbers. So you go y2, 5. Take away 1, which is your 4, and then on the bottom it's 4 minus 3, which is 4 plus 3. So basically you're going to get 4 over 7 anyway. Excellent. Now, find the equation of the line L. Oh, sorry, I forgot part H, did I? No, I didn't forget part H. Find the equation of the line L. Well, to find the equation of the line L, it's y minus y1 equals m bracket x minus x1. M represents the slope of the line. x1 and y1 represent any point that's on the line. Now it tells you that the line L represents the shop and the school. I can either use the point 4, 5 or I can use the point minus 3, 1. I will probably use 4, 5 because there's no negatives involved. Okay, so it's going to be 4, 5 is x1, y1. You're allowed to use any point on the line. So it's going to be x minus 4. This is going to be y take away 5. Now lads, you also need to get the slope of this line, alright? And we already found the slope to be 4 over 7. Therefore the m value is 4 over 7. Okay? So because you know that's 4 over 7, okay, 4 over 7 goes here. Okay, then we can see the denominator on the bottom. You need to multiply that by the y minus 5. So you multiply that by the y minus 5, you get 7y minus 34. Then you multiply the 4 by the x to get 4x. Multiply 4 by the minus 4 to get 16. Then you bring them all to one side. So you're going to get minus 4x plus 7y. You get minus 35 plus 16. But we all know that's minus 19. Equals 0. That's an acceptable answer where a, b, and c are all integers. They can be positive or negative. Another possible answer is to multiply both sides by minus 1. And you get 4x minus 7y plus 19 equals 0. I think either of those two answers are perfectly acceptable. Next thing we need to do is we need to find the tan of the angle. Work out the size of the angle A, and we need to give our answer in degrees correct to one decimal place. Well, if we go back to our angle here, we can say that opposite is 4, adjacent is 7. Tan is opposite over adjacent. So tan A is 4 over 7. It's an angle question. So we're going to use tan inverse 4 over 7. And then when we put that into the calculator, shift tan inverse 4 divided by 7. And what we get when we shift inverse 4 over 7 is we get, now I'm in radians. See the R on the top of my calculator? You need to go to shift, setup. You need to make sure you're in degrees, okay? And then you get an answer of 29.74. So I'm going to go for 29.7 there, okay? 29.7 degrees. Okay, so that brings us to the end of question 5, and we're going to stop it there.